Good afternoon to everyone who are joining us today. Welcome to all school students, teachers, parents, and all student UMS and UMS staff present in this session today. Thank you, and we meet again for today's session of STEM Speaker Series with Associate, my STEM Ambassador, University Malaysia Sabah. For those who join us for the first time, this STEM Speaker Series is getting full support from the Ministry of Science, Technology and Innovation, which aim to deliver unique and interesting STEM topics designed by subject matter experts to increase the interest of school students, teachers, and community alike to venture in the field of STEM. For any question from the audience today, please feel free to drop your question on the chat box at the right side of this YouTube live session. Please be informed that for today's session, a certificate will be given to school student and UMS student after this session is finished, and students have to fill in the form, which will be given at the end of the session through QR code or link to get the certificate. So please stay tuned with us. With us today is a distinguished academician from Faculty of Science and Resources, PMCHM TS Dr. Muhammad Sani bin Sarjadi. So how are you today, Doctor? Good afternoon.
Yeah, Alhamdulillah. Thank you, Izzat.
Alhamdulillah. So before we start this session, let me read a little background about our speaker today. So Dr. Muhammad Sani Sarjadi is currently an associate professor in industrial chemistry with the Faculty of Science and Nature Resources in University Malaysia Sabah. His PhD was awarded in 2015 and obtained from University of Sheffield, United Kingdom. His research interests includes organic synthesis and polymer chemistry and all aspects of industrial chemistry. He had published numerous articles in local and international referred journals and conference proceedings. He is associate member of the Royal Society of Chemistry, United Kingdom, Chartered Chemist AMRSC, associate member of the Malaysian Institute of Chemistry, AMIC, Professional Technologies, Material Science Technology, MT, and Malaysian Board of Technologies, MBOT. So without further ado, please welcome Dr. Muhammad Sani Sarjadi with his topic today, synthesis of conjugated polymer for organic solar cells application. So please be invited, Doctor.
Okay, thank you very much, Saudara Izzat. Okay, thank you very much for introducing my background. Actually, I have some, in terms of the expertise, focusing in terms of the organic and also specific in the chemistry, polymer chemistry. Izzat, can you see my slide? I just show that.
Yes, Doctor, I can see the slide.
Okay, thank you. Okay, before I proceed, my talk is I confirm that our audience today we have a student from the secondary and primary school, and then we also have maybe the peoples or maybe the parents and also our UMS student. Today, my turn to share in terms of the some topic, and then the topic is focusing in terms of the more in chemistry. And then under chemistry, we bring forward in terms of the polymer, and then the polymer is more in conjugated. Before I proceed, actually I'm introduce a bit myself. Okay, based on this name, you can see it got some series of the title. Okay, start with the associate professor. That one is referring from the achievement in the University Malaysia Sabah, and then we have a CHM. or underword. Actually, this is a more referring to the chemist Malaysia chemist professional. Okay, I'm one of the member under Institute Kimia Malaysia. That one is a institute under board for the chemistry background team, more in the chemistry people or chemists in this particular institutions, and then we need to fulfill some of the requirement in order to get this opportunity to member for this Institute Kimia Malaysia. And bring forward TS means the technologies. This is referring in terms of the your experience in terms of certain field. In my field, I'm focusing in terms of the material. Even though I expert in terms of the chemistry, actually not really expert. It's just my field of study in the chemistry. And then after 20 years in this field, and I apply for this material, I get this technologies, and up we got the doctor referring to the PhD achievement. That is in terms of the name. I think this is give some motivation to all the student out there to understand in terms of our career path. When you learn something in your future, and up you can get something not only in terms of your career, but in terms of your kepuasan lah ya. Alright, and then synthesis of conjugated polymer for application of solar cell. This is my topic today. And then for the first slide from the Google image, you can see the series of the panel. And then I confirm that everyone is familiar and know about this panel. Actually, this is referring to the solar panel. Okay, the solar panel, this is an alternative for the community to gather electricity energy from the sunlight. We can convert it this light with some chemical interactions, convert it to energy, and then can give our electricity. Okay, there are many benefits of going solar at home. Solar power technology has advanced and you can see it advanced and cost limited in terms of the if you want to buy that you use electricity from our generation means from the provider. But when we use this photovoltaic, they have 10 benefits, and we start with saving, reducing of the eliminations the cost from the electrical grid. Means we can generate in ourselves to get the energy from the sunlight, convert it to energy, and then economic protections. Again, electricity, of course, increase, and then adaptability means for the easily to put in this panel in anywhere if you want it, in the, like say in the rural area or in terms of kawasan-kawasan pedalaman kan. So more panel can be added to an installed system at any moments. And then environments, it can reduce carbon footprint compared with our current source, our current source. And then return investment, the initial investments is regained with the 6 to 10 years. And then commitment with the sustainable and environment. And then also we have free energy. Solar energy is a free and inexhaustible. And then we have a life span with the photovoltaic system have a life span about 25 years. Means boleh bertahan lama lah in terms of stability dia. And then independence, and also is got the benefit. Okay, saya punya ni tak boleh gerak. Okay, what is solar energy? Solar energy is one of the fastest in terms of growing environmentally sustainable trend in renewable energy. And then light and heat from the sun is converted into electricity using photovoltaic. Okay, photovoltaic is two words regarding in terms of photo, ini cahaya, and then voltaic. Voltaic means material yang boleh menghasilkan energy lah in terms of the electricity ataupun volt-time. And then solar panel installed on the roof and energy efficient homes and businesses know that solar energy is a smart investment that will benefit them in the long run. From this diagram, you can see number one is a solar panel. This is a convert sunlight into clean direct current or DC. Direct current yang kita gunakan di rumah tu, electricity. And then yang kedua, bila dia dah convert tenaga matahari, they can get a meter to storage, to storage the tracking electricity and coming to the from the utilities grid and then convert it to the kita punya source and back to the our household lah, inverter that convert direct electricity from the panel into usable electricity tools to power in your home. Okay, daripada slide ni we can see how solar panel works. Start with the matahari, pergi ke panel tersebut, and akan ada berlaku conversion yang kita akan terangkan sebentar lagi. And then the solar panel transform sunlight into direct current, and then DC current go to the inverter. Inverter menurunkan dia punya tenaga sama ada pergi kepada pencawang, pembekal ataupun kepada penggunaan in-house consumption, home consumption. Okay, di sini pun sama. Kalau kita tengok daripada tenaga matahari directly kepada panel tersebut, and then you have a type. Ini yang kita akan belajar hari ini berkaitan dengan junctions. Actually, this is the technology, is a current technology, and we need it all of a young generation to think in terms of this, to convert it all the cahaya daripada matahari itu membentuk satu material yang kita panggil sebagai panel ini untuk membekalkan tenaga electricity. Okay, this is in terms of some of the introductions for the renewable energy. We have renewable energy resources. Kita ada hydro power, kita ada biomass, bahan-bahan yang terbuang yang diguna pakai, and then kita boleh proses untuk bekalkan tenaga, and then kita ada tenaga daripada wind power. Biasanya dia akan ada di negeri-negeri barat yang ini kita ada windmill yang akan generate this electricity dekat dia punya resources ataupun dia simpan dia punya tenaga yang dia jana. And then kita ada geothermal, ini dari segi pemanasan lah biasanya geothermal in terms of the daripada sumber bumi. Dan yang terakhir yang ada solar, yang ini yang kita fokuskan pada ketika ini. Okey, merujuk kepada perkataan yang kita gunakan, yang ini adalah panel yang akan convertkan cahaya matahari ini, dan panel ini mengandungi photovoltaic, bahan yang berada dalam lapisan setiap ruang dalam permukaan solar panel ini. Okey, lapisan yang ada bagi permukaan solar panel ini, they have two types. Actually, they got many types, but in a big or in a main group, they have inorganic, inorganic dan organic. Okay, bila kita cerita pasal organic dan inorganic, this is referring to kepada metal, mengandungi metal ataupun bahan logam. Bahan logam digunakan sebagai bahan fotovoltaik. Kelemahan menggunakan bahan berunsurkan logam ini adalah bahan pencemar sekiranya telah habis digunakan dalam tempoh-tempoh tertentu, because this panel they have jangka hayat, the shelf life. So the shelf life after gone and then got the maximum in terms of performance, they will jadi bahan yang terbuang. Okay, they have a problem in terms of the decompose. This is the big issue in terms of the inorganic photovoltaic material. However, inorganic photovoltaic material is banyak ada di pasaran, dan yang selalu kita nampak itu adalah berunsurkan silikon, itu adalah photovoltaic berunsurkan inorganik. But for the organic is satu approach yang baru, merujuk kepada penggunaan bahan polimer. Polimer, they have a thin film polymer ataupun pakai dye, dye sensitive. They got a layer like macam plastik yang boleh menghasilkan electricity. Kelebihan in terms of the organic ini, dia dah lightweight. Ini adalah sifat plastik lah. Sifat plastik, lightweight. Bila lightweight, mudah untuk kita modify ataupun tailor, untuk patternkan dia, untuk kita modify. And then they have a low cost in terms of produce berbanding dengan bahan silika tadi, silikon, silikon ataupun mungkin ada material metal, logam. And then they have a excellent in terms of the flexibility. Ini yang saya nyatakan tadi, bila dia fleksi, dari segi ketebalan, dari segi add-on, kita untuk tambah dia dengan beberapa bahan yang berbeza, and then mudah berlaku, dan kita boleh kaji perubahan kadar dia menukar daripada cahaya kepada electricity tadi. And then easy of the fabricate. Ini easy of the fabricate, kita create lah ataupun kita hasilkan dia dalam keadaan berbagai kaedah, berbagai background berbanding dengan logam yang lebih heavy. Kalau kita mudah faham, kita ada besi dengan kita ada what call it, plastik, ataupun mungkin kita ada amorphous, bahan yang separa liquid, separa liquid. Okey, seterusnya daripada mosaic, this is in terms of the perbezaan silikon. Ini yang saya nyatakan tadi. We have a silicon, one is a silicon, and then we have a organic. Organic. The differences between silicon and organic solar cell is referring in terms of the transparent anodes. We have a transparent anode, and then we have the aluminium as a cathode. The transparent anode untuk dapatkan cahaya berbanding dengan aluminium, and then they have a polymer under organic. Under organic, they have a transparent layer, and then we have a fullerene. Fullerene ini adalah nama bahan aktif yang boleh menjadi bahan penderma. Warna oranye ataupun warna merah yang ada di ruang ini adalah polimer fullerene, ataupun kita panggil sebagai dia punya donor, untuk acceptor kepada polimer yang akan kita hasilkan nanti. They have a A and they have a B. We call it heterogeneous in terms of the mixture. Okay, for the silicon pula, silicon solar cell, they have a anti-reflection coating di permukaan atas, and then they have a front contact, dia ada base, dan base ni dia ada elektron hole and pair, ataupun kita akan panggil sebagai positif dengan negatif, P junction, N junction, or P N junctions. And then they have a external load. Okay, the demand for high efficient and affordable solar photovoltaic technology had resulted in the widespread research and development of the various technology, including the organic solar cell. Pada photovoltaic ni paling dekat sekali adalah organic solar cell yang kita bincangkan tadi. Bahan-bahan fluorine ataupun mungkin ada polymer, and then ada dye, sensitive solar cell, and also they have a quantum dot solar cell. Okay, ini maklumat fundamental berkaitan dengan photovoltaic system ataupun conversions in terms of the light. We have a source in here. Source kita adalah matahari. Dalam banyak pengetahuan, matahari menghasilkan range of the wave yang berbeza, sinaran yang berbeza. Termasuklah cosmic ray, alpha ray, X-ray, UV, vis, and then we have infrared, microwave, and radio wave dalam range yang berbeza. So yang memerlukan conversion di dalam proses sebaran cahaya matahari ini melalui visible light into the earth, and then we have this wavelength this wavelength with the frequency, yang mana dengan frekuensi ini dalam range visible light 380 nanometer sehingga 750 nanometer, ini yang akan memberi sumber kepada energi yang kita akan generate menjadi electricity. Okey, di sini ditunjukkan empat peringkat asas kepada pembentukan cahaya matahari menjadi electricity. Okey, yang pertama kita lihat di sini, ini adalah cahaya matahari yang kita fokuskan tadi. Cahaya matahari melalui UV. Okey, the step is we call is a generations of exciton. Itu proses dia lah. Generation of the exciton. Exciton ni merujuk kepada ini molekul yang terlibat dengan proses UV tadi. Generation yang dihasilkan akan ada dua konsep, iaitu P dan hole dan electron. They call it is a electron donating material, and this is normally is in terms of the conjugated, yang warna kelabu ni. Okay, yang warna kelabu ni, ini adalah polymer layer yang kita ada. Cahaya matahari masuk melalui UV dan dia generate exciton. Exciton ni combination antara hole dan elektron. Dia akan berlaku stage yang kedua dipanggil diffuse. Diffusions of donor and acceptor. Donor and acceptor is merujuk kepada sifat bahan material ini tadi. And then ada diffusion untuk dia berpisah slowly, dan dia yang ketiga bila dia dah diffuse daripada banyak-banyak dia akan diffuse untuk menghasilkan pemisahan itu. Pemisahan itu membawa stage yang ketiga, ataupun kita panggil sebagai formations of gemination pair. Gemination pair dalam keadaan single-single antara hole dan elektron. And then dia ada yang keempat yang dipanggil sebagai collections of electron. Bila elektron tu masuk aja, dia terus pergi kepada acceptant. Ini yang saya cakap tadi, acceptant yang warna di luar ni, pitch ini adalah acceptant. They call is a electron acceptant material ataupun fluorine. Fluorine antara wahan yang paling utama kita guna. Dia menerima elektron yang dijana daripada polymer conjugated tadi. Okay, ini adalah major step in terms of the networks. They have a cahaya matahari, polymer, generate kepada elektron bagi kat fluorine dan pergi kepada cathode untuk lengkapkan dia punya dita. Dia ada absorb, dia ada create, and dia ada collect for the electron. Seterusnya, ini adalah characterizations. Okay, kita ada banyak plastik yang menghasilkan electricity. Ada active material ataupun jenis-jenis polymer yang boleh convertkan cahaya matahari melalui UV tadi. Okay, untuk mengukur, in order to get the efisiensi, keberkesanan, banyak tak elektrik yang boleh dikonvertkan? Banyak tak elektrik yang boleh dikonvertkan? They have a formula. They call it is a power conversion efficiency in a percent. Normally, we need a 10% of a number. Hanya polimer ataupun bahan aktif yang mempunyai nilai boleh mencapai 10% efisiensi is the best in terms of the polymer tersebut. Formula bagi pengiraan for this polymer conversion PCE decoder, we have a voltage, voltage referring to the open circuit voltage, and then kita ada current, and they call it a short circuit current, and kita ada fill factor, fill factor yang memenuhi berapa energi ataupun elektron yang kita boleh himpunkan dalam fill factor, and kita ada input of the power. Okay, yang ini comparison in terms of the solar panel. Kita ada solar panel, kita ada monocrystal, kita ada polycrystal, and then kita ada amorphous. Amorphous ada dari segi color, composition, size, price, and efficiency lah. Ini yang kita utamakan dari segi nilai. Kita ada dalam 13 hingga 16%. Okay, yang ini different types of the solar cell. We have a positive and negative angle. P positive side content and exit of hole, while the negative side content of the excess of the electron. Okay, yang ini in terms of the configurations, configurations of polymeric solar cell. Okay, kalau tadi kita dah belajar PV is referring to the photovoltaic, photovoltaic merujuk kepada panel, solar panel, yang mana material polymeric sudah dilekatkan ataupun telah didesign dalam panel tersebut. Okey, berbanding dengan polymeric solar cell, ini adalah material yang ada, dalam struktur tersebut. Okey, untuk evolusi ataupun pembangunan bagi polymeric solar cell ini dimulakan dengan konsep bilayer heterojunctions. Bilayer heterojunction ini merujuk kepada ada 1, ada 2, ada 3, ada 4 stages, 4 layer, dan kita perlukan penggunaan cathode dan anode. Yang ini biasanya kita akan gunakan ITO atau kita panggil dia sebagai indium tin oxide, and then kita ada cathode. Yang cathode ni dikodomen ni ada option. Tadi kalau ada transparent kan kalau kita tengok yang awal. And then they have a conjugated polymer. Ini yang banyak series of bahan yang boleh digunakan for this polymer part. And then we have a fullerene, yang ini acceptor warna hijau, fullerene derivative. They got the electron accepting material, electron donating material. Matahari masuk, pergi kepada material donating, elektron akan pergi kepada fullerene. Berapa banyak elektron yang akan masuk kepada fullerene ini akan menghasilkan satu liter. The circuit is completed based on the electron donation tadi. Okay, after 10 years, they got the improvement in terms of, they call it is a bulk heterojunctions, BHJ. Kalau sebelum ni bilayer, bilayer layer 2 dengan layer 3. Sekarang ni dia go to the bulk, bulk. Ni konsep bulk. Konsep bulk, they got the blended. They got the blended. Blended maksudnya polymer dan actually dua-dua polymer ni cuma donating D dan acceptor bergabung dalam keadaan blended. So bila ada cahaya matahari masuk, is directly to the materials. Because still in terms of the circuit, they have a anode and cathode. And then this electron donating materials is going to get more surface contact compared with this. It's just one pattern in terms of the contact with conjugated to the fluorine derivative. Okay, this is in terms of efficiency what I talking about beginning tadi. Daripada bahan inorganik, isunya banyak digunakan tetapi bahan pencemarnya suka dikawal, and then they have a 40%. Now we need to focusing in terms of this new ataupun our current approach for the photovoltaic or organic photovoltaic. There's got a room to improve to equal in terms of the 40% achievement. Just now we got a 10% conversion. Matahari masuk, and then got the electron activate for the fluorine, and then got 10% conversion. For this is the example of the organic photovoltaic tersebut daripada gabungan kita ada carbazole, and then kita ada thiophene and benzethiodiazole. This is a PCD TBT, and then we have a PCD TID in terms of these combinations. Okay, daripada based on this diagram ataupun schematic, we can see it. They got a different chemical structure. We have C12H25 and we have C8H17 with the branches. These ada cabang. Yang ini ada cabang, yang ini tak ada cabang. Okay, dengan ada cabang, dengan tak ada cabang, they will show the different phase. Bahan-bahannya berbeza. Ada bahan solid, ada bahan liquid. Kita jangka dengan adanya perubahan daripada cecair kepada pepejal untuk menghasilkan bahan organik fotovoltaik ni akan meningkatkan nilai PCE. PCE kita ada masalah PCE. Ini PCE dia 40%, ini PCE dia 20%, ini inorganik, ini organik. Okay, this is a typical for the organic solar cell. We have argentum, P-dot ataupun this is a chemical for donations, pembekal elektron, polyethylene dioxythiophene, and then we have in here P3 for this is under active layer, and then we have electron extractions, bottom electrode and substrate. This is under this journal, journal, and then this also under example of the active materials, and that is for this introductions under solar panel and active material in the solar panel. Okay, bring forward specific for the polymer. When we talk about the polymer, is related a very large molecule made when hundreds of the monomers. Monomer ni sebelum dia jadi polymer, ini monomer. 1, monomer 2, monomer 3. 1, 2, 3, 4, 5. Okay, monomer. Oleh kerana warnanya semua sama, that is the same monomer. Same monomer. Join together to form long chains, and then the words polymer come from the Greek words meaning many, and meros is meaning parts, and plastic synthetic polymer that can be shaped by the pressure. And then this is the representations in polymer. They have alternating AB, and then they are random AA, B, A, B, A, and then block A, 5A, and then got the B, 5B, and grafted. Okay, and then they got the branch like this. And then this is like linears, branches, and then we have a star, branches, comb, and ladder. Got many. So the polymer. This is a conjugated. It's alternate. Alternate. double bond, single bond, double bond, single, the arrangement. This is a non-linear, non-conjugated. And this is the polymer conductivity. They have trans-polyethylene, polyfluorine, polyphenylene, polypyrrole, phenylene, polythiophene. This is the reference. Reference. The work done by them to find that, okay, untuk yang pertama ni kegunaannya adalah organic conductor, and then polyfluorine kegunaannya penebat, insulator, and then ada seterusnya lah, ada LED untuk TV ataupun display, polypyrrole, photoluminescence, and then we have a polyaniline, electronic device, and bergantung dengan dia punya sifat ni lah. And then this is a conjugated with the color. This is the series of the conjugated. Conjugated ni berwarna. And then this is got many polymer yang boleh digunakan untuk bahan aktif. Dia ada polyethylene, and then polythiophene, polythionophene, polypyrrole, and polyisotenanes, pidot dan sebagainya lah. Okay, this is in terms of the possible molecule assemble pathway of conjugated polymer. Polymer tadi saya dah tunjukkan dia pelbagai shape. Yang ini daripada dispersed polymer chain, and then go to the random coil, panjang dia. Bila dibentukkan cantum-cantum, dia akan jadi worm yang lagi panjang, end up kepada molecule solution. Boleh pergi yang liquid, boleh pergi yang pepejal. Sama juga dengan pre-aggregated polymer chains kepada more inner other pembentukan. Kita boleh sediakan polimer ini dalam proses pempolimeran. And then this series of the conjugated, ini yang kita ambil tadi range dia, polimer berada dalam keadaan semiconductor, sama sifatnya. And then this is under chem communications kepada donor acceptor nanohybrid photocatalytic, kepada PCDTBT, donor, and then kepada acceptor, fluorine, ada donor, ada acceptor, PC17. Kalau masih ingat lagi tadi ada layer yang ada 4 layer tu, so this is kind of the material yang kita gunakan. Uniquenya in terms of this conjugated, they have a colors, they call the colors. Okay, the most efficiency organic solar material tadi called is a PCBM. PCBM tu 6,6-phenyl C61 butyric acid methyl ester. Dan kita ada juga P3H3, dia kode polyacetyl thiophene. Okay, ini adalah polymer with fluorine. Ini all polymer, maknanya tidak ada fluorine sebagai acceptor. Dia kode donor dengan non-fluorine sebagai acceptor. Biasanya ini akan mempunyai nilai yang lebih rendah berbanding dengan nilai PCE bagi ada fluorine. Okey, yang ini merujuk kepada layer structure organic solar cell in traditional, we got the blend with the pedot and then got the metal oxide. Okey, yang ini pun sama in terms of the evolutions of the required efficiency. Kalau power conversion efficiency, dia berubah kepada berapa persen dia, berapa persen. Yang ini merujuk kepada proses, you have the light to produce the light, to release light in terms of the power. Kepada energi daripada matahari masuk and then give support kepada elektron untuk kumpul di anode dan cathode. Okey, seterusnya is proses penghasilan polimer. Kita ada banyak kaedah. Ini antaranya dimulakan dengan proses demineralizations, reductions, the conversions of this with NH, and then they have crystallizations daripada liquid going to the solid. And then we have other correlations. And in terms of the catalyst, kita ada gunakan catalyst untuk boron introduced into the structures and go to the style coupling reactions using a palladium and toluene as a materials. Dan akhirnya akan dapat combinations dua structure. Okey, yang ini proses seterusnya adalah menggunakan acid hydrolysis and then ester, re-esterifications under penutupan ring. You got a single ring in here, hasilnya akan dapat dua. Ini under adult condensations and move forward the alkylations dan juga pergi ke borylations. Ini proses pergabungan bagi monomer. Monomer tambah dengan monomer untuk hasilkan polymer. Ataupun proses ini semuanya dipanggil sebagai polymerizations. Polymerizations. This is a monomer 1. This is a monomer 2. And then this is a monomernya ataupun kita ingat sebagai polymer 1. Between these combinations, this is a monomer 1. Dan ini adalah monomer 2. Sama juga yang ini monomer 3, ini monomer 4. And then we have this as a monomer 1. Monomer 3 and this is a monomer 4.5. Okay, in order when we have that kind of the material, sifat-sifat bahan yang boleh digunakan. Okay, you all dah faham. Okay, kita ada solar panel. Layer solar panel itu dipanggil sebagai bahan aktif. Bahan aktif perlu dibuat, perlu dihasilkan. You have to produce based on this kind of the reactions tadi. Ini bahan-bahan yang digunakan daripada dia cecair, kita buat reaction sampai dia dapat solid ataupun semi solid untuk dapatkan thin film. Beberapa peringkat kita perlu cirikan dia, kita perlu tahu sifat dia. Pertama, sifat dari segi kita panggil dia sebagai organik tadi kan, organik. So antara alat yang boleh digunakan untuk mengesan sifat organik ataupun kehadiran elemen-elemen organik tersebut adalah karbon, hidrogen, oksigen atau mungkin ada nitrogen yang hadir dalam bahan tersebut. Kalau kita pergi kepada alat kedua, dia panggil sebagai Fourier transform infrared, spektroskopi transform inframerah. Alat ini akan menentukan kehadiran elemen-elemen ini untuk menentukan sifatnya berada dalam keadaan kehadiran kumpulan organik. Yang kedua, penentuan, yang ini kita panggil sebagai kumpulan berfungsi, functional group. Yang kedua, kita tentukan kedudukan bagi karbon dan hidrogen. Karbon dan hidrogen dalam susunan kimia tersebut. I confirm that most of you familiar in terms of the chemistry. When we talk about the chemistry, they will go into the chemical structure. When have a chemical structure, normally the structure for the aromatic ataupun mungkin linear combination between the carbon punya bonding kan. Okay. Carbon bonding tu boleh dibuktikan dengan magnetic resonance ini ataupun NMR. NMR ni akan tentukan kedudukan di mana karbon tersebut, adakah berdekatan ataupun bilangan karbon yang ada. Kalau boleh saya bagi contoh satu, yang ini contohnya, ada berapa bilangan karbon. Ini complicated sikit. Okey, yang ini contohnya, ada berapa banyak bilangan karbon yang ada dalam sini. Ada karbon sini, ada karbon sini, ada karbon sini, karbon sini. Sini ada karbon, ada 6 karbon dia. Okey. So, dia akan buktikan bilangan karbon. Okey, untuk FTIR tadi dia ditentukan berdasarkan dia punya wavelength, panjang gelombang. Okey, seterusnya ada mesin ataupun alat yang kita boleh guna untuk tentukan kepanjangan polimer tersebut. Kepanjangan polimer tersebut. Tadi kita dah belajar polimer ada rangkai dia panjang sebab dia monomer campur monomer. And then campur monomer. So dia boleh use rangkai yang sangat panjang. Kepanjangan gabungan monomer ini boleh ditentukan melalui alat ini dipanggil sebagai gel permeation chromatography. Alat menentukan kepanjangan polimer tersebut, rantai panjang. Okey, seterusnya kita nak tahu sifat bentuk dia daripada kanta, tapi yang ini more in scanning electron microscopy, mikroskopi dalam dia punya. You letakkan sampel, nanti dia akan ada beam yang akan pergi kepada sampel itu, dia akan nampak dia punya permukaan bagi polimer yang kita hasilkan. Sebab tadi kita dah cerita daripada liquid and then dia proses end up dia akan dapat pepejal ataupun solid. So di solid ada dia punya permukaan dia. Macam mana kita nak tengok permukaan? Menggunakan scanning electron microscopy, dan seterusnya kita ada XRD untuk tahu dia punya pecahan beta, susunan daripada shape dia. Dia ada bentuk persegi ke ataupun macam gula. Kalau you all pernah tengok gula, dia ada crystal structure, you will know dia ada structure of the compound. Dia ada 7 jenis. Kita boleh bezakan lah. Dan kita ada thermal, sifat kepanasan, kepanasan, glass transitions. Suhu berapa dia boleh mencair? Suhu dia boleh mencair. Alright, and then ini they have a glassware. Saya punya ada ini pula. Okay, seterusnya we have UVVs. UVVs. This one is referring to the wavelength in terms of the peak. They call the band gap. They call it a band gap. For this band gap, biasanya kita akan letak energy, berapa peak bagi material tersebut. And then they have a current, current for measure. Kita gunakan cyclic voltammetry based on the electrode. They call the 2 electrode. You have to dissolve your material, the polymer, and then daripada solution tu dia akan ada 2 electrode untuk ukur dia punya bacaan based on oxidation and reductions. Okay, this is in terms of comparison properties for this project. We have some of experiment based on producing for this conjugated polymer with this M1 and this M2, and this is a M3 and this is a M4. monomer 1, monomer 2, monomer 3, and monomer 4. We have this of a summary of the 15 compound produce 4 monomers, and up we get the polymers. Okay, the polymers is combinations with this P1 and P2. For the P1 is a PCD, PBT. For the polymer 2 is PCD, TID. This is the sifat for the properties in terms of the we have melting and boiling point. Start with the melting point, 149 to 145 to 149 degrees C. And then we have a start with the solid, and this one is using dinitrobromobenzene, and then we have this kind of FTIR to know the functional group. And number 2, we have this polymer to produce the polymer and the changes in terms of the FTIR significantly. We have 2 bromine here, maintain. We got the 2 for the aromatic. From the yellowish going to the yellow solid. Okay, this is a FTIR. No, this is a NMR, and focusing for the proton NMR. Proton NMR, we can see it numbering for the bilangan carbon yang ada dalam susunan itu untuk diukur di sebelah. Ini carbon NMR, bilangan jumlah carbon dalam unsur, bilangan jumlah proton dalam structure. Okay, this is sama juga. We have a yellowish, bring forward kepada yellow to yellowish, from 140 to 112 to 115 degrees C. Dia mencair, dia tukar sifat daripada solid kepada cecair, and then it's under reduction process. And this is under NMR. We have a proton NMR and we have a carbon NMR. Bilangan karbon dan bilangan proton dalam chemical structure. Sama juga yang ini compound seterusnya, compound 2, compound 3, perubahan dalam tindak balas, cyclization. Cyclizations, 112 is increasing to the 100, 12 is going to the 225. Kalau kita tengok yang sebelum tadi, nilainya adalah 112, dia mencair, sekarang dia dah berubah. And this is a FTI, carbon and hydrogen NMR, proton NMR. And this is a solutions, under solutions, liquid, with the hexyl decanol, alcohol, for the tosulate, and up together, compound 4. And move forward kepada hydrogen and proton, comparison between the FTIR. This is a FTIR in terms of the functional group. Okay, yang ini pun sama, compound 5, compound 6, compound 7 for the FTIR. This is under Suzuki coupling reactions. Compound 8, this is under bromonations, daripada solid white kepada yellowish, greenish, and move forward to the benzothiazole. Compound 9, from the liquid move to powder, powder ataupun solid. This is dibromobenzothiazole. This is referring to the conjugated. Already in the conjugated, we can see it alternate, double bond, single, double bond, single, double bond, single for the red. and go to the compound 10 is under diethylanophene, benzothiadiazole, number 10. This is referring to the NMR. NMR. We have a proton in here, and this is a carbon. Move forward to the compound 11. Compound 11 referring to the FTIR. The melting point is 129 to 152. And go to compound 12 for the NMR, and compound 13 for the FTIR, NMR, and up go to the second last, and then this is the last compound. In the amorphous formations, got the solid. This is black solid. The temperature for the melting point is 112, and FTIR is referring to the compound is this double bond, kumpulan-kumpulan berfungsi. Okay, this is summary, and then this is machine for the NMR. We have referring to the NMR data. One is under high. Is that?
Yes, doktor.
Boleh dengar lagi
Boleh, can.
Oh, tadi terputus sekejap
Habis sudah?
Belum, lagi sikit lagi. Alright.
Okay.
Ya, sebelum ni boleh dengar Saya takut.
Boleh, jelas doktor.
Alright, thank you. Alright, and then this is a summary of the compound and the list of the properties, properties, FTIR, and then we have the machine to know the organic conformations. And this is the long chain in terms of the polymers. We have molecular weight. Based on this molecular weight, number of the molecular weight and weight of the repetitions of the monomers. And then this is the surface using a scanning electron microscope to know the morphology, surface morphology of a compound. And this is the thermal properties, and up we have the UVVs, ultraviolet visible in terms of the peak, to know the gap efficiency. Adakah dia mencukupi untuk dicapai 10% conversions of the electron. And we have a HUMO and LUMO in terms of the current can pass through the compound ataupun the polymer itself. And we have this polymer 2, same one under NMR, nuclear magnetic resonance, to know that is the numbers of the carbon and the hydrogen. All right, this is the repetitions in terms of the monomer. Repetitions of the monomers under this gel permeation chromatography, and the surface morphology under scanning electron microscope, and the thermal properties. Thermal property, we have thermogravimetry, percentage in terms of the degradations, and DSC ataupun differential scanning calorimeter in terms of the glass transition. Maksudnya dia berubah daripada solid dan the melt untuk menjadi glass sections. Okay, this is in terms of ultraviolet UVVs to know in terms of this band gap, the band gap value 1.73. Okay, the rest is just for on for the electrochemical properties comparison with the beberapa plastik-plastik ataupun beberapa compound-compound yang berbeza. So that's last as conclusion. Polymer solar cell show good promise in terms of the development, low cost photovoltaic alternative. And then structure and systematic research are required in the field to successful utilize the fluorescence advancements or advantage in terms of the organic solar cell. All right, I think that's it for this sharing today. Thank you very much and thank you for the attention. Okay, pass to the Izzat. Okay, Izzat.
Thank you very much to Dr. Muhammad Sani. It was very interesting and wonderful topic and very well presented today. There's so much I have learned from Dr. during this presentation, such as I just found out that there are many types of solar that has been used in our industry, and I have found out that how we can identify polymer using some machine that can identify the polymer itself. So we move to our next session, which is Q&A session. So if any of you have question, please write it down in the chat below and I will read it, some question that has been asked in the comment section from the YouTube live. So I have a question for Doctor.
Alright.
Ada yang bertanya soalan ni Doktor. Dia tanya
Okay.
soalan, macam mana kalau hujan, macam mana solar system itu berfungsi sekiranya hujan berlaku? Itu soalan dia.
Okay. Actually, there's no related in terms of the water. Okay. Lights, maybe I can easily to show that the formation tadi kan. Okay. Right. This one. Kalau diikutkan in terms of the, okay, this one. This is the diagram ataupun dia punya susunan dalam dia dah bercunting. Nampak kan Izzat? You can see it.
Nampak Doktor.
Okay. This is in terms of the structure, design of the. When we talk about the panel, they have a layer. They got the 4 layer. Introductions, I also mentioned that they have a cathode and anode arrangement. This is covered with the anode. Normally we can use indium tin oxide, oxide untuk bahagian penyaluran. Kalau ada hujan dengan sifat dia yang stability, tidak ada interaksi antara hujan, we can relate it with the water H2O to changes with this chemical. I think there are no interactions between this water, raining water, to these materials because of the stability of the conjugated polymer. Even move forward to bulk heterojunction also, they have no they are stable and no interactions at all with the hujan. Itulah. Itu jawapan untuk soalan kalau hujan. Okay. Another one, in terms of the storage, like say, saya panjangkan sikit berkaitan dengan matahari. When we expose the sunlight, dia akan berlaku bila dalam keadaan maximum in terms of the light. Like say, daripada pukul, contohnya lah, daripada pukul 10 pagi hingga mungkin pukul 5 petang. Pukul 5 petang. That is the process is happen. However, like say in a light condition ataupun macam night, day, not day, night, they still exposed to the environment because we have that kind of the thermal properties. Thermal properties ini juga memainkan peran ni sebab dia akan ada keep in terms of the heat for the kita punya materials. Alright, Izzat. Okay.
Okay, Doctor, thank you for the answer. Next, we have question from Jom Follow. Doctor, in your opinion, polymer solar cell should be applied in which industry to earn more money as much as possible nowadays?
Yes, actually not in terms of the, okay, when we talk about got the two direction. One is in terms of the supplier. Like say, you guys have experience or maybe exposure with the apa ni, berjual beli. Okay, kalau kita tengok kat Shopee pun banyak produk-produk berunsurkan solar panel sebagai sumbernya. Maknanya bila kita beli lampu ada solar dia, means kita akan jimat dari segi penggunaan elektrik. Kalau kita mampu untuk dapatkan stock untuk kita jual for this kind of the apa ni, tools, lampu-lampu yang ada solar together is very good. Kita jimat sangat dari segi penggunaan. And itu one. Another one, in Malaysia they have encourage or maybe some campaign, the government or maybe the entity land, sewakan you punya kawasan yang luas. Contohnya di atas bumbung. Kalau ada pengalaman yang mungkin nearby, mungkin ada from KK, Sabah area, we have one Borneo ataupun mungkin in the community, community hall, Dewan Community. Bumbung-bumbung tu dipenuhi dengan panel. Itu maksudnya bumbung itu disewa oleh sesuatu agensi untuk generate tenaga elektrik, dan elektrik itu akan disalurkan kepada pembekal tenaga elektrik di Sabah. Kalau di Sabah lah kita ada SESB, yang mana SESB ini akan bayar kepada orang-orang yang landkan dia punya space ruang tu kepada SESB kerana membantu generate elektrik daripada solar panel tersebut. Itu respon lah. Misal ada dua. Satu, menjual bahan-bahan yang ada solar panel tu integrated. Satu lagi, dia sewakan dia punya ruang-ruang. Okay, Zat?
Okay, Doctor, thank you for the answer. I hope it will answer the question that has been asked from Chan Bon Hope. So, another question from Adeline Munga Tinggal. Doktor, untuk memilih jenis solar, biasanya industri lebih memfokuskan kepada jenis bahan atau budget?
Okay, itu je soalannya kan? Is that? Okay, I think
It's
alright. Okay, thank you, Adeline, for soalan. Okay, for this, okay, they have two kind of the business. One is as user. Kalau user, dia akan menggunakan bahan yang paling minimum sebab in industry the money is very important in terms of the usage. When we produce it, we try to find that can get the more money but low cost. So like my slide before, I explained in terms of the variations of the polymers. They have many types of polymer can use it. However, when you can get a low efficiency, dia punya harga tu lebih rendah. Mungkin harga bahan untuk polymer itu sedikit mahal untuk diproses ataupun dijadikan bahan aktif, tetapi kadar untuk diserap elektron tu lebih tinggi. Maknanya when after done the polymerize to get the active layer, so they can enhance the good electricity, so benefit to the industry. Kalau industri tu nak gunakan solar cell, mungkin dia akan cari solar cell yang dijual dengan harga yang murah. Tapi kalau you sebagai pengeluar bahan aktif tadi, you will find out that the best energy efficiency yang paling baguslah, yang paling rendah. Maknanya if you got a very short distance in terms of the movement of electron akan banyak berkumpul dan akan generate elektrik yang lebih besar dan banyak penggunaan boleh diguna berbanding dengan band gap yang jauh untuk elektron tu bergerak, so they will go the very minimum ataupun kadar yang lebih rendah. So that's my answer. Okay, is that?
Okay, Doctor, thank you for the answer. I hope it will answer the question that has been asked from our student Adeline Munga Tinggal. So I think that's all for today. We hope you all enjoyed this amazing and interesting presentation by our wonderful speaker today. So the link for registration and e-certificate is now being shared for school students and UMS students. Please fill in your details and answer the simple feedback questionnaire so you can receive the e-certificate from our session today. So once again, I want to thank you, Doctor, for answering those questions and for those amazing presentation. Also, I want to say thank you for all the audience today for your participation. We look forward for seeing you in the next STEM speaker series, which is scheduled on 5 April 2022 at 10 a.m. And the title for the next webinar is Syok ba Tagal? Memahami kepentingan manusia terhadap alam sekitar melalui sistem tagal. So it was a pleasure to have all of you with us today. With this, we conclude the webinar. Thank you and see you again. So thank you, Doctor.
Alright, okay, thank you Izzat. Thank you juga kepada audience. Semua thank you. Pelajar UMS, mungkin ada sekolah rendah, sekolah menengah dan cikgu-cikgu, ibu bapa semua. Alright, thank you. Jumpa lagi. Assalamualaikum. Thank you.
Ya, Dokter. Waalaikumsalam.
Okay. Okay lah Izzat kan? Kita boleh macam mana? Kita tunggu ataupun?
Dah habis dah, Doktor. Boleh apa?
Alright. Okay, thank you. Jumpa lagi.
Okay, Doktor.
Assalamualaikum.